Scott Bly. Why don't you come on up, and he's going to tell us a little bit about some API security. Thank you very much, and it is all yours.
Thanks a lot. Can you all hear me? We're at war. I'm going to say that again to make sure everybody can hear me. We are at war. Cyber breaches currently are an active part of armed conflict, if not a leading indicator of physical warfare. Russia's first cyber attack on Ukraine took place in December of 2015. That's fully 7 years before the invasion. China, North Korea, Russia, these are all nation-state actors that are actively targeting US government data resources as well as the political parties on both sides of the aisle. So it doesn't matter if you're conservative or liberal, we're all being targeted. Now, the problem is that the government isn't the primary target. According to Mandiant, Google's incident response firm and cybersecurity arm, financial services firms are twice as likely to be targeted as government orgs last year. North Korea funds many of their activities via ransomware and Bitcoin payments that are generated as a result of this activity. Organized crime is part and parcel to Russian government activities, and this includes cybercrime. Chinese hackers have been exfiltrating intellectual property from US firms for years, so none of this is new. This is exactly what's been going on, and these are all acts of war. Now, the war has come to us, unfortunately, those of us in this room that are responsible for development, operations, and security of these organizations. We're left on the front lines, and the United States government is not coming to help. Regardless of what's happening in the headlines right now with CISA and DOGE and all of this other stuff, there's nothing new about the fact that there's a fundamental disconnect between law enforcement requirements to gather evidence by setting the bait and making sure that the bad guys come in and they're gathering evidence. That takes time. But what does a private organization need to do? They need to get back to revenue-generating activities that are profitable as quickly as possible and with minimal cost. Now, this is before we even touch upon the complexities of international jurisdiction. Quick show of hands. How many of you in the room are to fire up a VPN quickly that makes you look like you're in Japan or Europe? Maybe this is to get around Netflix requirements or whatever, right? So if you can do that in a matter of seconds, how is law enforcement supposed to keep up? They can, but it takes time. And that's the exact opposite of what we need in business, which is speed. Now, not only is the government not coming to help, they're partially responsible. Let's all remember that the NSA's stockpile of zero-day attacks and their other elite tools were hacked and stolen and sold on the dark web 10 years ago. So this is part of the reason why we're seeing attacks rise. If it seems like we're seeing more headlines, it's because we are. This is what's happening. This is the world we live in. This isn't marketing fluff. So unfortunately, the bad guys now have access to the same capabilities as the good guys, including all of the AI that's being hyped. The bad guys only have to succeed one time. The good guys have to be successful every single time. Cybercrime now costs $10 trillion annually, and according to IBM, the average cost of a data breach is now about $4.9 million. But that breach brings with it costs not just from remediation, not just the direct costs, fines, consulting fees, but there's also indirect costs like business impact, reputational impact, lost intellectual property, lost trust. Each one of these things has a cost. Oh, and I almost forgot. There's also a cost for all of the free identity protection that we're getting 8 to 10 times a year, right? So all of that has a cost, and your organization is the one that has to bear that cost. Large firms face greater financial risk in the aggregate because the volume of attacks against them, because there's a nice juicy pot of gold at the end of the attack thread, they may face that larger financial risk directly, but smaller firms face a greater risk essentially. SMBs are hit more often by total volume because there's so many more of them, and if they're hit, they have a direct impact that has a bigger impact on their bottom line. IBM or Target, these large organizations, they can all withstand a breach. They're going to take a hit, but they can make it. A smaller org, bankruptcy is not off the table. There was an organization in London recently, I think it was in London, certainly in England, $100 million revenue hit by ransomware, wiped them out. They couldn't recover because the bad guys also took out the backups. That's $100 million in revenue, and that's not enough to recover. how much revenue is necessary in order to be able to recover from an impact like that. Those of us in the room are left holding the bag as a result of all of this. Our code, our applications, our infrastructure are the front lines in an economic war that is very, very real. And every new innovation we put out there is a weapon that can be used against us. As he said, my name is Scott Bly. I'm the Director of Security Technologies for SIS, Systems Integration Solutions, former no-name security. It's where I learned a lot about API security. I was at AWS where I ran the Security Improvement Program from Enterprise Support. Thank you all for coming out. I'm going to move very fast because there's a lot to cover, and I'm the last thing standing between you and beer. So I don't want to be that guy. So we're going to move quickly. Agenda. We just talked about what the stakes are. I'm going to review that periodically. Introduction, I already covered that. Why API security? I want to cover up some misconceptions between DevOps and DevSecOps. And any technology solution requires three things: technology, people, and processes. I'm going to cover all those, but I'm mainly going to focus on technology. And last but not least, how do you get a hold of me? Because I want to talk to every one of you if you have anything to ask about. Now, why API security? Why does this matter? 85% of web attacks are now API attacks. So if you've got a web app that's out there, odds are good that instead of seeing a traditional web app attack, what you're seeing now are API threats. Why is this? Main reason, I mean, we could say it's greed, right? Gordon Gekko in the movie said greed is good, right? Well, what everyone's trying to do is take advantage of the fact that data is the new gold. If you're writing application, you're putting it out there, your organization wants to take advantage of the data that you have made available, and the best way to do that is through APIs, because APIs have direct connectivity into your data resource, whether it's transforming the data, accessing it, you're loading it in, whatever it is, an API is the way to do that at scale. That's why we all have jobs, that's why the pace of innovation has been so fantastic. Now, we're here at DevOps Day. DevOps has been wildly successful over the last 10 years. We now have the ability to get code to market as fast as the marketing guys want, and we're able to do it repeatably, and we're able to do it reliably. Your talk today was fantastic and was about how do we make sure that we have reliability while being able to ensure that our engineers aren't losing their minds. Important, and DevOps is part of the way that that's been able to happen. But the problem is that pace of innovation has also left the security guys in the dust because they can't keep up. A little bit down below, I mentioned that there's a 1,200 to 1 ratio of developers to AppSec engineers. How do the security teams keep up with that pace of innovation? There's a problem. As a result of that disparity, you have increased vulnerabilities on your web apps, on your APIs, and there are also interdependent vulnerabilities. A breach to one API, because of your business relationships with partners that are consuming those APIs, you have the ability to impact not only your own as a result of a breach, but you also impact your partner organization's data. That's a big problem. One of the other things that I see people say very frequently is, I've got APIs, we've just launched this great product. How are you handling API security? You need to worry about that. Because our APIs are internal. Good. At least your network firewall is going to protect you. At least your phishing campaign is going to protect you. Because ransomware never is effective, right? That never happens. All of our network firewalls are doing a great job of protecting that. And your phishing emails aren't actually making their way to the end users and nobody clicks on them. So there's no problem with your perimeter, right? So just because your APIs are internal doesn't mean that they're safe. If a breach can come through and impact a network resource that has data that can be ransomwared, or a malware can be implanted on something that's behind your firewall, that doesn't mean your APIs either. Did that come out right? I think you get the point. I may have said it backwards, but you know what I'm getting at. So the way to fix this, as we all know, is to fix it in dev before it makes its way to production, because it's exponentially less expensive to resolve these problems before they make it to prod, and less risky, less downtime. As I mentioned, 1,200 to 1 ratio of developers to AppSec engineers. It's really hard to make this happen at scale. Now, the last thing I want to leave you with before I move on and start getting into the specifics here is that this is a monumental, gigantic thing to take on, but it shouldn't be a burden. You do it in small pieces, iteratively, as you go through development cycles and as you go through releases. It should be an iterative lift, not a burden. Now, when we talk about API security, so that's kind of the frame, that's the foundation. This is the stakes and what's going on so far. When we talk about security, I was at No Name. These are the No Name security, now Akamai security, foundational pillars of API security, and I happen to agree with them. There's discovery. I think on one of the previous presentations there was, if you can't see what you can't protect. Absolutely true. So discovery is one of the key elements. You need to understand what your API landscape actually is. Assets, inventories, change detection, network mapping, reconnaissance, these are all things that let you know what your API landscape is, what your inventory looks like. I'm going to talk more about that shortly. Posture management. This is really the first miniature step in shift left, and we'll talk a lot about that later. But when you're talking about posture management, you're talking about how is your API behaving, and what is it doing? Not necessarily whether it has been breached already. But posture management talks about infrastructure, and it talks about configuration, etc. How do you prioritize? What are the vulnerabilities you want to address? That's one of the ways that you have to manage the volume of vulnerabilities that are present. Another speaker was talking about this as well. You need to be able to prioritize. How do you increase your signal-to-noise ratio? Posture management is part of that. You only have so many resources to be able to remediate problems. Posture management helps you to prioritize. Runtime protection, you can think of as shift right. This is, did a bad guy do a bad thing at a particular time? This is your SOC, this is your SIM. You're seeing these activities, you got to chase them down, and you got to stop them, right? So that's runtime protection. Also suspicious behavior, abnormal behavior, anomalous consumption of APIs, anomalous data flows, right? And the last piece of the puzzle is, in the no-name world, it's called testing. I'm going to reference no-name because I know it the best, but testing is about shift left. It's about testing your code, testing your APIs before you have your code running in production environments. So that's an important piece of the puzzle as well. Now, DevOps, it's DevOps Day, so presumably we all understand DevOps, but also I know for a lot of your organizations, even if you're employed, even if you have DevOps in your title, your organization may not really understand DevOps. A lot of them may only stop at a software factory, which is what's represented here. All of my graphics here, by the way, are from the Department of Defense DevSecOps strategy guide. You can Google it. It's a really fantastic resource. But kind of foundational, right? This is, you've got code, it's going to go to a repo, you've got your different environments, you've got your pipelines, you're going to test, you're going to integrate your code across your application, and then you're going to release it. Once upon a time, that was on a CD. Nowadays, it's day if you're Google or whomever. Is my audio cutting out pretty bad? All right, so whoever's listening online, sorry about that. Can you hear me when it does get cut out? You're good now. I tend to be pretty loud. So this is great. This is the foundation of DevOps. You can get code out, you can do it reliably. Infrastructure as code, you can even blow out an entire environment and replace the whole thing, right? The cloud, very, very powerful capability. Even if you're doing it on-prem, you can do it with software composed resources. Now, DevSecOps, a lot of times we talk to customers. They say, oh yeah, we have DevSecOps because we're doing this. We have DevOps pipelines, we have CI/CD pipelines, we've got sneaking. Yeah, we did it. This is good. This is very, very good. But it's not enough. It's not the full picture. I'm going to show you how the DoD represents DevSecOps. And it's not this. This is just one piece of the puzzle. Technically, I think it's three. DoD represents it this way. Now, when you're talking about DevOps, you have your various stages. Planning, develop, build, test, release, deliver, deploy, operate, monitor, feedback. It's a continual cycle. You may be running in your dev cycle for a little while. See if I can get my little clicker to work. Is it going to do it? Yeah. So it's going to go You're going to be on the development cycle for a little while, and then you're going to release code, and then you're going to be in the operations cycle for a while. Right? You're going to go round and round and round. Do you like the sound effects? Round and round and round, and you're going to kick it back. We discovered problems that we need to fix. We got a new feature, whatever it is. You're going to learn from the previous mistakes, and you're going to feed that into your development cycle again. And you're going to release more code. Notice that each one of the red shields around this diagram are a security phase that wraps your entire DevOps process. It's not just in your IDE. It's not just at build. It's not just in your pipeline. It's the whole thing. So what I'm going to do is quickly make my way around here. How am I doing on time? I forgot to set my timer. On the planning phase, is this helpful, or can you guys read it without me trying to struggle with the little magnifying glass? Is it big enough without this? It's all right? Okay, so I won't do that. So at the top, you have threat modeling. Threat modeling is at the planning stage. You're considering writing a thing, so before you write the thing, you map it out, and you see, where are my problems? I'm going to publish a web page. I forgot HTTPS. I remediate that by using standard operations to be able to get HTTPS, so I'm encrypting my web traffic. That's threat modeling before you've written any code. Next up is secure coding, right? Does your organization have secure coding practices, approved libraries, etc.? Do you have tools in your IDE that gets into security as code, so that you have the ability to make sure you're using best practices during the process? And then, this is the thing most people think about, is SAST, right? Static application security testing, right? Sneak is a very prevalent example. There are many, many others. What these tools do is they look at your code in your repo or in your IDE or in your build stage to determine, are you using libraries that are approved, or are you doing things that are inappropriate, etc.? Are there problems with your code the way that it was written? The next step around the cycle is DAST. That's dynamic application security testing. Notice that it takes place later in the stage, in the progression. It's because for DAST to work, you have to have an environment that it runs in. SAST can just look at your code. DAST has to be in a running environment. This makes it harder. This makes it more complex, especially when you start talking about modern software application architectures like microservices. DAST works really well on a monolithic app. You have a certain number of endpoints, it's going to do stuff, and you're going to get output. When you take that and multiply it across 150 different services, it gets really hard to accomplish this. So DAST is an important piece of the puzzle in your security profile, in your posture, but it's hard to do. So it gets skipped sometimes. It's more difficult to accomplish, and it's more expensive. Next up, we all know about pen testing. It's an important piece of the puzzle as well. Is it on? Digital signatures for your code as it's being released. Get over there. I'm going to stop worrying about the magnifying glass. Digitally signing your code is important to make sure that you're proving that you're the one who released the code and that someone's not consuming inappropriate code or code that's been manipulated. Next up, as we get back up to the right-hand side, once we're on the operations side, we have secure transfer. Think Microsoft Update. This is a good example. They've got a whole platform that's designed to make sure that you are getting updates for code securely, that you're getting the delivery that they're intending. Your configuration in your deployment. This has to do perhaps with cryptographic agility, using declarative security instead of imperative security, where your security controls are, instead of being built into your application, they're in the wrappers around your application. Maybe they're configuration files, maybe they're infrastructure components, maybe you've abstracted that out completely to infrastructure that runs, but the security configuration can happen separately from your development, right? When you separate those two, you have more ability to control that. Cryptographic agility, a good example is you can't use certain crypto suites in certain countries, right? So you don't want to rewrite your application every time. You want to be able to just strip out the US-based crypto and put in something different, right? So that's cryptographic agility. It's an example of secure configuration and having that abstracted away. Security scanning, I think of this primarily as vulnerability management. You have an environment that's running, and you've got your data center or your cloud environment where you've got AWS Inspector or any other tools out there that accomplish this for you, and you're scanning. Next up is patching. This is related to the previous example of secure transfer with Microsoft Update, right? Patch Tuesdays, you update it, you got to get it out there. The entire time that your code is live and it's running in the in the operations side, you have to have patching take place so that you have security updates or feature updates. Whatever it is, it's still a patch because your code's live. Until the day that it's dead and gone and dormant and archived your data, you have code that's running. Next up is audit. We all know about auditors. Please don't think of audit as the bad guy. The auditors are there to help you do a good job. The auditors are there to check to make sure you've accomplished the baseline, which is the requirement of compliance, right? But guess what? Those are table stakes. The audit is an opportunity for you to partner with people that have an objective view of how things should be going, and the best auditors can be viewed as an outsourced CISO that's just there temporarily to look at your environment and provide you with an honest assessment of how you've done in the security that you say you're doing, right? Be friends with them, work with them. Everybody's going to come away much better, because the purpose behind all of this is to make sure that your organization is more secure, so that you don't end up funding North Korean attacks or Iranian attacks or the other things that are there as a result of the data that's being leached out of your environments. Next up in the list, security monitoring. Think SOC, think SIM, Grafana, your observability platforms, etc. And last but not least on the list is security analysis. This is what happened. Hopefully you have a blameless post-mortem after an incident. The Kat that was up here just a few minutes ago talking about incident response, I don't know if she mentioned this, but hopefully your organization practices psychological safety. And what that means is when somebody sees something, they can say something. They can say, I think this happened because of this purpose, and they're not going to get fired for it. The security team is not responsible for a breach. The organization is, right? The security team should have been asking for resources, and hopefully they've been approved, but guess who ultimately approves all that? It's the C-suite. That's why the CISO is now criminally liable for certain activities. I don't have any examples of that at the moment, aside from the, who is the big one? The Uber guy, right? If I'm remembering that correctly, right? So now CISOs have a lot more skin in the game, so hopefully they're paying closer attention. So this is the totality of the DevSecOps life cycle according to the DoD. Notice that it's not just about CI/CD pipelines. Not every organization has to do every part of this. When you get to the point that you have a complete posture, hopefully you have all of these capabilities built in. But it's impossible to boil the ocean. Do what's right for your organization according to your risk appetite and what makes sense. Now, when we bring this back to API security, we're going to focus on a few of these. Each one of my clever little arrows here are pointing at something that is most related to APIs, right? Secure coding, security as code, that's a little bit different. You can philosophically have an argument that that's still relevant, that it has to do with APIs, but APIs are about code consumption. They're about the transformation of data. You can think of them as the door, right? If you've got a data resource here, you've got a door that's going to allow someone through to access that data. The API is the door to gain access to the data or to gain access to the logical functions that manipulate that data or upload it or whatever's happening in your code, right? But the API is the access portal to be able to make that happen. So not every part of the cycle is relevant. Now, what we're primarily going to talk about is the technology piece, right? On the technology side, this is a different view of that same infinite cycle, right? And you can see what I'm going to do is primarily talk about DAST, which is there in the middle under testing, right there. And over here we have security scanning. And down here at the bottom we have security monitoring. This little thing's a little harder to use than I anticipated. But this view is exploded out, so instead of it being an infinite loop, it's one long cycle to go through the whole thing. Some people like this view better. I prefer the infinite loop one. But what this does is it shows on the technology side, I'm going to talk about these three things primarily. Am I doing on time? Decent. Now, technology, all you have to do is pick a tool, right? All the vendors are here so ready to sell you something. This isn't that kind of conference, so it's not quite as bad. Behold, the API landscape. These are all of the vendors that are out there that have something to sell you that has to do with APIs. Easy, just pick one, right? Even with my magnifying glass, you can't see it. Now, that's not really fair because this isn't just security. But if we zoom in and say, okay, let's just talk about security, there's still 98 pure play security vendors on the market. And this is as of a year ago, right there, 98. These are the security pure play vendors. There's plenty of other things that are related, discovery, risk management. There's threat management that's down there. Come on. Threat management, privacy, right? There's lots of options that are out there, but even this is still so overwhelming. How do you choose, right? The vendor came in and he said, I'm the best API security vendor, blah, blah, blah. Okay, great. Of course you are, according to your metrics. But those metrics aren't appropriate for your organization. You need to make your own decisions. So, how do we do this? This is an open source focused conference, so let's talk about OWASP. Used to be the Open Web Application Security Project. Now it's the Open Worldwide Application Security Project, if I'm not mistaken. They have an API security tools list. I'm subscribed to the GitHub repo. It's updated all the time. I'm not sure if the list is updated, but there's plenty of comments flowing, so it's active. Of the 56 tools, when I prepared this a little while back, of the 56 tools that are available on that site, 36 are commercial and only 20 are open source. What's interesting is that when you're talking about the 4 pillars, discovery, posture management, runtime, and the active testing shift left component, think of it as testing. Of those 4 pillars, I'm going to leave discovery out of scope for this part of the conversation because discovery is kind of inherent in any one of these. If you're doing something, you've discovered it, so it's implied. On the commercial side, there are 13 posture management tools and 13 runtime tools. Of those 13, 12 of each has the other component. So only one of those doesn't have the other piece. So generally speaking, posture and runtime go hand in hand. Because what they're doing is they're essentially looking at what do you have running. So you have to have access to the data, you have to have access to the API information flow, and you've got to be able to do something about it and observe it. So those 2 capabilities kind of go together. Of those 36, 35 also have a testing component, and 22 of those testing tools don't have either runtime or posture. So this is just kind of an aggregate view of what does the API security industry look like. This is, as of several months ago, there are more newer solutions out there. On the open source side, there's only one posture tool, and there's only one runtime tool. And neither of those, one of those, the runtime tool doesn't have testing, and the posture one does. So what does that tell us? Now, in my view, what that tells us is it's much, much harder to build a runtime and posture tool. It requires investment that needs to have a commercial payback in order to pay for all the developers that are necessary to build the infrastructure. And I can tell you from being at No Name, it is hard. It's hard to be able to integrate these security tools into your running production environment to blow things up. Some tools are inline and are intended to be able to block on day one. Other tools are out of band so that you can't have, theoretically, you can't have a production outage that impacts your running workload. But that's not always the case. So there are different approaches to these security tools than, that have different capabilities and advantages and disadvantages. You want to choose the one that's appropriate for your organization, for your workloads, and for your risk appetite, and for what you're trying to achieve. Now, the other piece on the open source side is that there are 19 testing tools on the open source side because it's more direct. You have a tool that can run against a piece of code. That's a document or a document repository. You scan it. You come to your security conclusions. App is a great example of this. And it lets you know, do you have vulnerabilities? There are newer ways to do this that are more exhaustive, more comprehensive, etc. But that's the lay of the land largely with regard to commercial versus open source. Now, this is the No Name UI. I'm not here to talk about No Name, but I'm using it as an example of the tool that I am the most familiar with so that you can get an idea of the kinds of things you should be looking for if API security is something that's of concern to your organization. If all the things I've talked about so far resonate with you, then you should be looking into what should I do, right? With all those tools out there, how do you make a decision? This is a view of an inventory page out of the No Name platform, and what it's doing is it's showing you host times path times method. See if the little thing here helps. So you've got host times path times method. Why do you have them broken up like that? A lot of organizations say, oh, we've got like 10 APIs for our app. We're going to get a tool. It's going to scan them. Great. They fire it up, and they have 1,000 APIs, and they're stunned. They're like, whoa, 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 what do you mean I have 1,000 APIs? That's crazy. I only have 10. No, you don't. You have 10 applications. You have 10 things that you thought about as an API, but every single path, we have the car registration API. Yeah, but it has 6 or 7 endpoints in and of itself. You have your get, your put, your delete method, and this is just talking about a REST API. When you're talking about GraphQL, it's a whole other beast. Now, at its most basic, your inventory should tell you what your hosts, your paths, and your methods are, and each one of those is its own line item in any tool that's going to identify these things because each logical function, each method has a completely different business purpose, a different logical purpose, and a different attack surface, right? If you have a delete operation, What's your concern about a piece of data that's behind that? What could happen if it's abused? It could delete something, right? Whereas a put or an update or a get, you're not as worried about that being manipulated to delete data because it's different, right? That doesn't mean that they can't be. It just means that that's the business function, the logical function of that method is different. Now, the other thing you want to look for when you're considering one of these tools is the other capabilities, the other visibility you have within your inventory. Maybe you have the concept of risk. Sorry, is it visible? Can you read it from where you are? So you have risk. There's maybe authentication. You can determine what kind of authentication is being used for your API. Is it internet facing? Are there existing security problems that have been found? You want to understand your landscape. Up at the top, you have changes and data types and infrastructure. You want to understand what you have. That's discovery. When you start thinking about security, this is the posture piece, right? Think of it as vulnerability management. A vulnerability scanning tool is going to identify vulnerabilities that you have in your code or in your infrastructure. API scanners are going to do the same thing. In this particular case, what you want to do is you want to have something that's going to tell you what did it find. In this case, we have an API accepts an expired Java Web Token. That's a problem because Java Web Tokens are there to make sure that you're not using long-lived credentials. I'm Scott, my password is password, cool, I can get into the API. No, that's a bad idea. But even if my password is password, if I'm using tokens, they're only going to exist for 3 hours, and that's abstracted away from the logic of the code, the token itself is what provides access to the API and the data resource rather than my terrible password, right? So your Java token needs to be able to expire in order to honor that short lifetime. Now, unfortunately, there are plenty of times where an API is still going to accept it even though it's expired. So that's a problem. In this case, the tool is telling you, here's your problem, here's why it's a problem, and it also gives you some hints about what you should do. In this particular tool, you have the ability to look at evidence. Those are the specific calls and responses that were used. You can pull all that data up, and you can look at it and go, here's the data, here's the proof that this is a problem. Now, on the runtime side of the world, you have the same idea, but you have a point in time. Now, remember, vulnerability management is about what could go wrong, hopefully before the bad guys have figured that out. Runtime is bad things already happened. It's shift right. The concept of shift right is think of a timeline. You know, on the right-hand side, so for you, it's over here. On the right-hand side of the timeline is now and the future. On the left-hand side of the timeline is things in the past, right? So development life cycle goes, hopefully I've got this right from your perspective, but you start writing code and you go through your timeline, you release the code, and then over here you've got the code running in operations, right? Over here is where the bad guys are going to do a bad thing to your live data where you have customer data that's exposed, etc. That's shift right. It already happened. It's too late. You just want to stop the bad guy, right? So that's why you have detection time, activity, when was it updated, what are the things that are happening that are more like a SOC or a SIM that are going to let you know what did the bad guys do at a certain time? Or is it anomalous behavior? Or is it my API is being consumed faster than I thought? Is that an indicator of compromise, or is that just the inventory being updated at the retail store once a month because that happens all the time? So time is important when you're considering runtime. Now, when you're looking at this from a runtime perspective, there's also the concept of an attacker. Somebody did the thing. Something accessed the API. Whether it's an IP address that's the most specific information, or whether it's a JOT token or a user account or whatever it is, hopefully your tool has the ability to show you something that is a SOC-like environment that you can use as a way to investigate if you don't already have tools that accomplish this for you, right? Any tool you choose that has to do with runtime should integrate with your other tools. If it's a runtime tool, it needs to integrate with your SOC, your SIM, your security team will know what you need. I know this isn't a security conference, so maybe some of these terms are not super familiar, but your security team will know what they are. If you are a developer or an operations person and you're responsible for running APIs, you want to know, hey, we're worried about the security of our APIs. What does the security team need? So you need to make sure that whatever tools they're using, their existing workflow, is compatible with the tool that you're choosing as your API security platform of choice, right? So you need to be able to do something with this data if you have existing tools, and if you don't have existing tools, you need something that provides that for you. In this particular example, we have bad guy doing a thing, And for example, on the previous slide we had, it was a API input validation attack. They're in the top line, say. And then over here we look and see, okay, so what did the dude do? Well, here's his API input validation attack at the top. And then you can also see there was an access attempt with the missing JOT token, I think is what it says. But you can see the history of what that person was up to. So you can view their data. You'll hear people talk about Splunk as a SIM, where they can look at all the data that was involved in a series of activities. You can go back and pull the logs and see what was somebody up to, and where's the malicious activity that caused the problem. The ransomware hit at 4:30, at 4:29 you see the cryptographic functions start to run on a half a dozen machines, and before that you see them crawling around and doing these things on the network. Those are all SOC activities, SIM activities, SIEM, Security Incident and Event Management. Your API security tool needs to feed into those so your security team has access to that and has actions that they can take. In this particular case, the no-name tool has the concept of blocking. No-name's an out-of-band solution, so it can't block on its own. You have to integrate with something that has infrastructure capabilities in order to block that traffic. Some tools are inline, meaning they insert themselves between your workload and between the customer and the running infrastructure on the back end, right? It functions more like a WAF. When it's something like that, WallArm is an example. You have blocking ability on day one. You turn it on, you're seeing traffic, you see something, you go, oh, there's a bad guy doing a bad thing. Block, boom, right there. Other tools that are out of band, you have to add that extra piece of configuration in order to connect into your either WAF, web application firewall, or your load balancer, or your network firewall, whatever you're going to use to stop the bad guy with that specific piece of information. It's this IP, it's this JOT token, whatever it is, you need to stop that. So something has to be able to do that, and that's a piece of infrastructure, whether it's inline or out of band. Now, the technology piece. Next up is processes, and I'm going to cover this really quickly. On the processes side of the world, we have, on the left-hand side, security analysis. That's after things have happened, how are you going to feed that information into your planning efforts that then kicks off your threat modeling. APIs are vulnerable to threats, so you want to consider them in your threat model. As we get over to the middle of the screen, we see penetration testing. There's API penetration testing that's very important. Security configuration is up next. Does your application, does your API accept deprecated cryptographic algorithms, for example? Are you using a function that is no longer a good choice? That's an example of security configuration for APIs. Java web tokens that are expiring if you have a piece of infrastructure that handles that instead of your code directly, which is how it should be done, I believe. Next up is security patching. Your APIs are going to be updated. There's inventory management that goes with that. If you've got API version 1 and you release API version 2, if there was a security reason for that, you've patched it, you've updated it, but you still need to deprecate that old one, because if version 1 still exists, even though your infrastructure doesn't call it, even though you're not publishing it, if it's still there, somebody could still leverage it. You just go into the URL, change change V2 to V1, and all of a sudden, perhaps, you're still able to use the deprecated insecure endpoint that did exist. If you haven't gotten rid of it, it may still be there. So that's a problem that can come about as a result of patching that you need to do. But that becomes an inventory management problem. And last, security audit. Again, your audit should be able to verify that you've done the security things that you think you're supposed to do. Now, when we're talking about audit, PCI compliance is important. Anybody here responsible for PCI workloads? Yeah. So PCI, as of, I believe it was March, so this month, you now have PCI version 4 as an API security requirement. So guess what? You're on the hook for everything that I'm talking about. Your auditors will tell you what you need to do. Obviously, the punchline for all of this is if you need help with any of this, call us, right? Now, the last piece of the puzzle, and this is why what I told you about earlier, is the people part of this. This is the most important part. As she said in her excellent talk this morning, people are the ones that do all of this. The machines aren't doing it automatically. It's people, it's engineers. But what we have with Dev, Sec, and Ops is 3 teams, developers, operations teams, and security teams that are all incentivized differently. They all are organized differently. They all have different priorities that are competing. If you're a developer and you get a call from the security guys, what do? What's about to happen? Am I in trouble? Right? Does that sound familiar? I've seen it. We go review API findings for vulnerabilities, and the developer comes in, here's my workload, we ran it in the test, and how did I do? And the next guy comes in and goes, how did I do compared to the guys before me? And it's not about that. Remember the concept of psychological safety? When you're reviewing these things, it should be a safe place. And you do that by breaking down the silos and getting it to where your security people and your developers and your operations people know each other. They work together. But you also need to have places for developers to learn from the security people, and for the security people to learn from the developers, right? So a way to start that process is with a DevOps or a DevSecOps Center of Excellence. Some organizations go as specific as having an API Security Center of Excellence. Maybe that's too specific, but start with DevSecOps Center of Excellence, a repo that's there for people to be able to put all the best practices, your standards, your practices, get them into one place so that people know where to look, so that it's not a mystery. They know how to get a hold of your security people. In the best case scenario, you have an Amazon style, I was at AWS, I mentioned, they have this concept of a two-pizza, which is microservices architecture applied to business function. What that means is each team is responsible for their own work output. Developing a product, supporting that product, securing that product, updating it, etc. with a two-pizza team, meaning one team that can be fed by two pizzas. That's microservices architecture applied to business concepts, right? Now, when you have that and you've got the developers and the operations team and the security team all being fed by those two pizzas, you have a group that's working very tightly together to support that one very controllable workload. Not every organization can do that. So what do? You start with the Center of Excellence concept, you share best practices, technical trainings. I've seen CISO panels talk about, we have these problems where we got to break down the silos, but how do we do it? And they don't get any farther than technical trainings. Where's the imagination? Come on. What's the best way to get together with people and talk about problems? Pizza and beer, right, for the win. So get your people together, just have them go have fun. Don't just have the developer happy hour, have the developer and the operations people get together. It's hard when it's remote, right? Obviously the security people too, I'm not trying to exclude them, I just missed it right now. The other thing I want to mention is resourcing. I'm a big fan of a 70-20-10 or a 60-20-20 split. What do I mean by that? Your day job, the thing your job description actually says is only 60 or 70% of your time. What do you do with the rest of your time? 20% of your time should be spent working on the job, not in the job. Identifying ways to improve the process of the work that you do. This is how you accelerate the flywheel of how the work gets done. If you just keep doing the day job, you will never get ahead. Mathematically, you can only fall behind because the only other solution is to just keep hiring more people, right? Innovation is about improving things. Working on the job is how you have innovation about the job. The other 10% or hopefully 20% of the time is about professional development. How do you make yourself better at the job or acquire new skills? You learn the security things. You go volunteer, whatever it is, whatever your organization allows. These are C-suite problems, but hopefully you can go advocate for these ideas. Gamification is another one. You kind of referenced gamification earlier. When you're running these tests and determining what are you trying to accomplish, make it fun. Come up with an incentive. You know, the carrot's better than the stick, right, in terms of motivation. Social events I mentioned, and the hardest one, but probably the most important, is cross-incentivization. Your developers are there to get code out to market fast. Your operations teams are there to make sure that the application, that the workload is running. And the security team is there to make sure that it's secure, right? That you don't get breached. Those three priorities don't have a lot to do with one another. And neither do the bonuses that people receive for doing a good job on their workload, right? For their work output. I don't have an answer to this, but I would propose that identifying a way to cross-incentivize those teams so that they have a financial incentive or a career incentive to help each other accomplish those goals is going to go a lot farther and get your people to work more closely together and break down those silos. Now, just to bring it all back home, remember, the reason why all this matters is because we are literally under attack all the time. Your organizations are constantly being threatened. This is just the first slide again. I just wanted to make sure I remembered to bring it back home. So, the reason why this is so important is because we are at war. That's the sad truth. And it's not going to get any better, it's only going to get worse. Hopefully, we can all make a difference about this. That's all I've got for you. Any questions? Any comments? Any arguments? Scott, you're full of it. All right. Like I said, I don't want to stand between anybody and beer or pizza or whatever you're going to go do. Thank you so much for your time and being an attentive audience. I appreciate it. And thank you, DevOps LA. Thank you.